Hello friends, good evening. Welcome back to our channel AlpTalks. This is your Lakshmi Vati. Today we are here to discuss about generator protection. So generator is one of the important component in the power system. So without which entire power generation and everything is halt. So how to protect the generator? If it is any issue is there, anything problem is there, if any disturbances, so we have to take generator off the circuit. So huge lakhs of it is amount also is going to waste. Apart from that, huge public is going to affect from that. So all the generation companies, whatever it is there, who are generating the electricity, whoever having these bigger generators, and it may be in hydropower plants or it may be in normal thermal power plants or in other wind power plants also. These generators plays a major role. So we have to protect it. So how we can protect it? Let's go into the details. Yeah. So this is the introduction. So we know that generator, whenever we have one prime mover is connected to the generator, and whenever it is prime mover is rotating due to the external force, then there will be generation of EMF and everything. So that whatever the power is generated, that is we are going to fed to the power grid. Similarly, the for operation of the generator we need a field windings, we need a DC excitation system. So this is the three systems we can say broadly, which comes into the mind when we discuss about the generator. So let's go into the details. Here you can see, for example, here you have electrical circuit of the generator. So there are different things, the things are involved. So let's go into the things. So here you can see, this is the alternator, you have stator and you have a rotor, and the rotor you have a field winding, and it is excited by externally shaft mounted motor. So for that motor we need again excitation field. So that excitation is fed from the alternator itself. From the alternator itself, whatever the voltage is getting generated, we are taking that voltage, and the part of it we are giving back to the excitation. So whatever the power is generated, we are connecting that to the unit transformer. Here the unit transformer comes into the picture. So that unit transformer gives the output and is given to the HV bus. Here this is, we can say, step-up transformer. So for the rotor, we have a very big shaft. Here you can see this is the shaft. So for creating the rotatory motion. So here you have bearings at the end. So for how we are going to create this rotating motion? This we are creating rotating motion through turbine. Here you can see high pressure turbine, and here you can see low pressure turbine, and this is the turbine setup. So whatever steam is there, how steam is generating, here you can see. So right side, whatever the coal is there, we are taking the coal and we are flaming it in the boiler. So we are using air and pulverized coal we are sending, and we are using forced draft fan here. So whatever the flame is there, so coal is getting burnt, and with that heat, the whatever the water, cool water, whatever it is flowing, that water gets heat up and it is converted into the steam, and it is fed back to the high pressure turbine. So here you can see, here whatever the electrostatic precipitator is there, it will be used for ejecting all the gases into the environment. Here you can see you have chimney, here you have induced draft fan here. So all the harmful things or any particles, we will absorb it, and only air we will release into the environment. So here you can see whatever the steam is there, that steam we are giving to the steam control valve, and high pressure turbine we are giving to the high pressure turbine. And here you can see speed reference. So for we are taking the speed reference from the actual generator by sensing it. So that input also we are taking here. So whatever the leftover steam is there, that is we are again giving back to the boiler, so that it will get heat up. So whatever the exhaust and final stream is there, leftover steam, that is going to be condensed, and so we are going to use some cooling tower also here. Here they will use water spray technology is there. they will use one pump there, so it is keep on cool and the water is again used for reused. So this is the generator setup, whatever it is there. So let's go into the little bit more details here. So this is the single line diagram of the generator setup. Here you can see it is grounded through some resistor, some NGR, neutral grounding resistor, or sometimes small transformer also we will use. So here is generator transformer is there. We will say unit transformer. Here you have main CB, main circuit breaker is located here. So you have EHV bus. So this is the step up transformer, whatever it is, generator transformer. So we are going to up to the EHV bus. So and hence that is connecting to the grid. Unit transformer we are using here. So whatever if any auxiliaries are there in the substation, we will use for supplying those appliances. So here let's go to the little bit more detail. This is the generator circuit, how generator electrical circuit looks. So we will say alternator. Here you can see it is like a 3-phase system, phase A, phase B, phase C, everything is there. Here main circuit breaker is there. So that what we are going to connect to the generator transformer. So only thing, if you want to trip this generator alternator, then we are going to give trip command to this circuit breaker. So how we are going to give trip command? You can see grounding transformer. We used grounding transformer here for earthing, and it is ground resistance. Through resistance we earthed it. So how we are going to give the trip command, that is also matters. So here little bit come to the excitation circuit of the generator. Here you have excitation control system. This is the field circuit. So you have this is the motor here, the DC machine here. It will generate the supply whatever it is required for the field. So this is the field suppressor. So you have field winding of generator here. So field interrupter, and DC system is isolated from AC ground. That also you can observe here. This is the setup here. So there should be separate grounding here for AC and for DC as well. So various faults and abnormal operating conditions. What are the various faults we can see in the generator alternator? So electrical faults. There can be electrical faults. It can be mainly we have two items. One is a stator, another is a rotor. So in stator there can 3-phase stator winding is there. In rotor we have field winding. So what are the probable faults in the stator? So you can have phase fault, you can have interturn fault on the same phase, you can have ground faults also on the 3-phase stator. And what are the chances for a rotor? In rotor mainly we can have short circuit to ground, because as it is moving, as it have moving parts, so there are chances for short circuit to ground. So, and we have some abnormal operating conditions also. It can be electrical or it can be mechanical. So what are the abnormal conditions electrical point of view? So for example, stator, 3-phase stator winding and field, there can be unbalanced loading from the load. Unbalanced loading also can cause abnormal operating conditions. And in the field winding, loss of excitation, whatever the excitation we are giving to the alternator, it can be lost due to some reason, due to some failure in the auxiliary or any equipment or anything, then there can be loss in excitation. So these are the excitations with respect problems with respect to the electrical side. So mechanically, what are the problems we have? Mechanically, there can be faults like loss of prime mover and overspeeding also may happen. So these are the various abnormal conditions in a turbo alternator. So stator phase and ground faults, longitudinal differential scheme. So here you have, this is the stator winding, you can see it here whatever I am highlighting. So the stator other terminals are grounded. We can say this is a star connected, so Y connected winding. So it is grounded to the resistance. So what is if, say for example, stator is healthy, then we are measuring currents at both sides of the stator winding. Here you can see we mounted a CT here, we mounted another CT here. So those CTs will sense the whatever the current is flowing through it, it will give reading in the secondary. So those readings we took it. So those, for example, if both CTs are if this alternator is healthy, then it will carry same amount of current on both sides, right? Then as we joined CT1 and CT2 in a series in opposite manner, so they will cancel each other, so there won't be any current passing through the circuit, so the relay won't be activated. But let's think that there is some problem in some fault in the internal winding, there is some issue. Then what happens? The current will be different in both the CTs. In that case, there will be some operational current will flow through this whatever the coil is there. Then that coil will give trip command to this circuit breaker. Then the circuit breaker will be cut out from the supply. So that is the thing. You can see here. Here you have a circulating current and trip and bias. So differential. This is the differential protection. So longitudinal percentage differential protection we are using here. So how it is different from power transformer and generator. So power transformer, primary and secondary voltages are in general different. That is true. In power transformer, volt ampere is the same both sides, but voltage and currents are different. So primary current is different, secondary current is different. So we need different kinds of CT in the transformer. If tap changer is there, that is again different case. So in generator, it is not like that. We have same voltage, same current in normal cases both sides. So same voltage CTs we can take on both sides. CT1 and CT2 can be of same ratio. So turns ratio of CT on the two sides also same. Voltage same, turns ratio same. That is one good thing. So tap changer, no such tap changer is present in this alternator. So differentiation between this is the differentiation between transformer and alternator. So we have another one, transverse differential protection in the alternator itself. For example, say this is the A phase A winding, it is carrying 7000 amp and another phase carrying 7000 amp. Say for example, here you have transverse protection of generator winding means phase B for example. So here phase B is having two parallel paths. Say some internal some fault is there here. Say for example interturn fault is there. Then what happens? It is carrying 3000 amp. It may carry 3500 amp. So there is some difference, right? So what we will do is we will install some CT here and another CT here. Two CTs we will install it. So the current carried by these two CTs are different. So this is the one. You can see this is one loop here. This is one loop here, simply one loop. So in normal conditions, both parallels will carry same current. Then it will be zero across this relay, whatever relay is there, tripping relay. It will sense nothing. Whenever there is a difference, there is some faults in the both parallel paths. Then there is a flow of this mismatch in current. Then the relay coil will operate and it will give some tripping command to the alternator circuit breaker. So you can see it here. Now in this case it is flowing only 6500 amp. So 6500 means there 500 difference is there, right? That's why it will give some command now. So this is the one of the best protection method for the alternator. Yeah, this is guys. Thanks for watching. If you have any questions or comments or anything, then please comment in comment section. If you want any other topics to be discussed in this AlpTalks channel, then please comment those topics also. So I will make videos on that. Yeah, I made some couple of videos on jobs and some other transformer related stuff, and some live videos also there. So go through those videos. I hope you will enjoy those content also. Thanks for watching. We will meet in next video, guys. Bye.